Hello everyone. So today I'm going to brief you with an important topic from aldehydes and ketones, that is Aldol reaction. So let us see what Aldol reaction is. So Aldol reaction. Now in this reaction, two molecules of aldehydes or ketone containing alpha H react with a base for say NaOH to form beta hydroxy aldehyde, which is called aldol, or beta hydroxy ketone, that is ketol. So two molecules of aldehyde or ketone containing alpha H react with the base to form beta hydroxy aldehyde, which is known as aldol, or beta hydroxy ketone, ketol. So let us see the mechanism of this reaction. So basically, first say I take acetaldehyde. This is my acetaldehyde. Now this is my carbonyl carbon. The carbon adjacent to this carbonyl carbon is my alpha carbon, and the hydrogen attached to this alpha carbon are called alpha hydrogen. So I can easily see it is having alpha hydrogen. So this is my alpha hydrogen. What I do is I have a base. So what happens? This base will abstract this H, right? And the electron pair of this bond goes to this carbon. So what do I have? I have CH2 minus C double bond H. This is your carbonyl. Now this carbonyl, if you see carefully, this is resonance stabilized. And this is an enolate ion. So this is basically your resonance stabilized anion. Now this carbonyl will react with another molecule of this acetaldehyde in the manner that I have CH3 Now look here. So this now acts as a nucleophile. You can say as a nucleophile. You know that this is your electrophilic carbon. This bond breaks like this. So I have a partial positive over here. This will attack on this electrophilic carbon. And what do I have? O minus. I have H, and this is CH2 and C double bond H. Right? In the next step, I perform the hydrolysis. What do I have? I have CH3, COH, CH2, CHO. If you see carefully, this is your 1, 2, 3, 4. Or you can also write that this one is your alpha carbon, which is adjacent to this carbonyl group, and this one is your beta. So this is a beta hydroxy aldehyde. Or aldol. Now till the formation of aldol, this is your aldol reaction. But what happens if I heat this product? Let us see. If I heat this product, basically what happens, there is a removal of water molecule like this. there is a removal of water molecule from here, and what do I get? What do I get? CH3 CH double bond CH CHO. Now this is your alpha, this one is your beta, so can I call it alpha beta unsaturated aldehyde? Alpha beta unsaturated aldehyde. And this is, and from here to here, since there is the condensation of two molecules with an elimination of water molecule, I call this step to be the aldol condensation. This is your aldol condensation. So I hope you got the difference between aldol reaction and aldol condensation. So till the formation of an aldol, that is your aldol reaction. Now after the heating of that aldol, I end up getting alpha beta unsaturated carbonyl compound. This step is from aldol condensation. So this is your aldol condensation. So this is your aldol condensation. Now similarly, I can take ketone. For example, if I take acetone, you know, in the presence of, for say, NaOH, what happens? I end up getting this kind of anion, right? And I have another molecule of acetone. This will attack here. This goes like this. So what do I have is CH3, C, and after hydrolysis, I have something like this. So this is your alpha beta unsaturated ketone. Now what happens when I heat it? There's a removal of water molecule, elimination of water molecule, and what do I have is and this is your mesetyl oxide. This is your mesetyl oxide. This is called mesetyl oxide. So this is again an example of aldol condensation. Now what happens? Now if you see carefully, like for example, if I take two different aldehydes and both contains alpha H. For example, if I take ethanol and propanol, what happens in that case? So if I have ethanol and propanol, you know, both are having alpha H. Both are having alpha H. So what happens? So basically, I end up getting the combinations of, like for example, if I take the carbonyl of ethanol, and the another molecule is ethanol itself, that means the carbonyl is also of ethanol, and the other molecule I am also taking ethanol. So what happens in this case? So the carbonyl is of the same molecule. So what happens? And similarly, I can have the carbonyl of this, that means I have propanol, and the carbonyl is also of propanol, and this carbonyl is also from propanol. So in that case also I have, basically these are the examples of self-condensation where I have the carbonyl of the same species as the carbonyl compound. So similarly, if I have propanol and its anion, so these are your examples of self-condensation. These are the examples of self-condensation. Whereas if I take the carbonyl of ethanol, and another molecule if I take of propanol, or I take carbonyl of propanol and another molecule of ethanol, then in this case I end up getting products which are from mixed aldol condensation. Mixed aldol condensation. So basically I have a mixture of products if I take these two as my starting molecules. So to avoid this, to avoid the formation of this mixture, what do I do? Cross aldol condensation is suggested. Now what is cross aldol condensation? What is cross aldol condensation? I take one molecule of aldehyde or ketone, basically of aldehyde, which is not having alpha H. For example, I can choose benzaldehyde. So I can choose benzaldehyde. So I choose one molecule which is devoid of alpha H, and another molecule of aldehyde or ketone which is having alpha H. Aldehyde or ketone containing alpha H. In this case, I won't have the mixture of products, and this is what I call cross aldol condensation. Now, when I discussed with you the formation of mesotyl oxide, if you say carefully, this reaction can go further. How? You know that I still have alpha H present. So what if I take the carbanion of this mesotyl oxide and I react it with another molecule of acetone? Let us see what will happen. So what I'm saying is, I have this basically mesotyl oxide like this. So if I form the carbanion of mesotyl oxide like this, and I have another molecule of acetone, so what will happen? This will react here. This goes like this. So what happens? CS3, C, and double bond CH, C double bond O, CH2, C double bond O, and CH. C double bond O. This is CH2. Just a second. This is CH2. Yeah, I'm so sorry. This one is C double COH and CH3. This one is CH2, COH, and CH3, CH3. Now again, if I heat it, there will be the elimination of water molecule like this. So what will happen? So what I get as the final product is, I'm writing it here. This is CH3, CH3, double bond CH, and this is the single bond C double bond O. This is your CH. This is your CH double bond C, CH3, CH3. And this is called boron. And this is your yellow crystalline solid. So these are some of the examples of aldol condensation or aldol reaction.